So welcome to this video to help you with directions on a quiz and to refresh you on factoring a trinomial and also putting something into vertex form. All right, so to graph things. So you could be asked to factor this. You also could be asked to graph it. Okay, and there are several different ways you could graph this, and I'll show you at least one. And factoring, well, the first thing you always look for when factoring is to see if there's a common factor in all of the three numbers. And here I can see they're all even numbers, so at least 2. Anything bigger than 2? No. 2 divides out of all of these, so 2 divided by 2. In the beginning, we can factor 2 out of that, and we get x squared left over because 2 times x squared would be the 2x squared, the first term, plus 2 times 5x would be 10x, minus 2 times, I think, 14 would be the 28, right? And then I can continue. That's equivalent to the original function, which is f of x, right? That's my original mama, daddy. Well, that's not the parent function, but that's the original function. So an equivalent to that is 2, and I know I can continue to factor this because it wouldn't be completely factored. It wouldn't be correct if we left it like that, because I think that this one is not prime. I think that this one actually has 2 numbers that I can find that I can make this into 2 binomials two binomials multiplied. So x times x is x squared, and I just need 2 numbers, and I'm looking at negative 14, which is the C number, and I want to find factors of that. So 1 times 14, one of those is a negative. I'll just let it be at that. 2 times 7, 2 times 7 is 14, yeah. So it looks like I've got my pairs, and one of them has to be negative, and they have to add up to the middle number. So I'm looking for something that adds up to positive 5. So I think that if I had that as a negative, 7 and minus 2, plus 7 and minus 2. And you can put them in anywhere you want in those 2. So we have 3 factors. Yay, we factored it. We could graph it, kind of. That gives us some information to graph the function, but we've been learning about something different. The first thing we learned about is to find the axis of symmetry, minus b over 2a. And in this case, that would be negative 10 over 2 times 2 is 4. So the axis of symmetry on this is negative, well, 5 over 2 is 2.5. Negative 2.5 is where the axis of symmetry would be, and also where the x-coordinate would be, right, of the vertex, right, negative 2.5. So we could do that, but when we have one with a coefficient in the front like this, one thing to think about is for test number 3, very soon, we will need to be able to complete the square. So to complete the square, if it's not already in perfect square trinomial, we can complete the square by simply looking at we need the coefficient of the a term to be 1. So I'm looking at the first 2 terms, so I'm focusing right now on these first 2 terms, the 2x squared plus 10x, and I'm going to move the negative 28 over. So I have this 2x squared plus 10x minus 28. And as you get better at these, you can combine one step or something like that, but for now it's good to... So that's just moved over for convenience. And I want to factor out a 2. That's my first step, because I got the x squared alone, right? Plus 5x. And I want to complete that square, minus 28. Let's put the 8 a little bit nicer. Okay, so half of 5 is 2.5. And I picked one with decimals, sorry. Half of 5 is like 2.5. So 5 over 2 And if I square it, I get 25 over 4. 25 over 4. And you guys can get some decimal for that if you want. That is my perfect square, and my equivalent binomial squared, you should know the vertex form by now. X plus, we keep that same sign in the middle. And here we have 5 over 2, or 2.5. But we added 2 times 25 over 4, which is 25 over 2. We added 25 over 2. We have to take off 25 over 2, whatever that is. And you can do that yourself and get some decimal. Negative 28. Take away another 25 over 2. 12.5 is 40.5. Is that right? I don't know. Check it. Double check me on your calculator. So this would be the vertex form, and we know where the vertex would be, for example. It'd be at negative 5 over 2, or negative 2.5, whatever that is. And then negative 40.5, if I got that one right. So we've got the vertex form. It's easier when you've got an easier function to start with, so you don't get decimals.